Hello and welcome again to my workshop. Today we're going to go back to basics with the CNC machine, or the CNC programs actually. What I'm going to do is I have, it is a split log, and this is Tasmanian oak. It's a piece that I've just pulled out of the firewood pile, really, but this was cut more than 3 years ago and it's well and truly dried out, but there's no splits in it. So what I'm going to do is in 3 different programs, and that is AppCamp, Mach 3, and if I got enough time I'll also do it in NC Studio. And what I'm going to do is write a short program, show you how the program's put together then, in these 3 programs to surface this flat with the CNC router. So you can just get a hunk of wood and actually turn it into something that you can do something with. And then we're going to, in the next video, I'll put together in ArtCAM a 3D relief of an eagle, I think, coming to land, and we'll machine it in the surfaced piece of oak. And I'll show you how to do all that, show you how to set the machine up to cut it, and we'll see how things go. Okay, so first of all we are going to open up the wizards in Mach 3, which is simply done like this, and you can choose from many different operations to construct G-codes. But in that case, I think what we're going to do, very simple. Although we're surfacing, it's very similar to cutting a pocket, so we're going to use this one. And it brings up this wizard or dialog box. Now, so all you really need to do is fill in the information that is asked for here. The first one, okay, what tool are you going to use? Well, we're going to use a 25mm cutter. This is in millimeters, by the way. And there's a couple of little things that might catch you out here, and I'll explain them as we go along. So we highlight this and we say 25.0 millimeters. Now you must press enter after each time you fill this in, because if you don't press enter and move on to the next one, it will revert back to the settings that are here. So okay, so we've told it 25mm for the cutter. So step over. Now this is in percentage of the diameter, so that's a little bit much. We want to be conservative with this. Okay, so we're going to say we want 33%. Okay, that's fairly reasonable. I mean, look, it would do 100%, but I find if you just step over minimal like that, or reasonable amount, it gets the job done, but it leaves a much cleaner finish. Okay, plunge feed and rough-in feed. Now then, this is where you can get caught out, because ArtCAM operates, when you fill in the dialog box on ArtCAM, that is in millimeters per second. Now this in Mach 3 is millimeters per minute. So if I left it at that, it would be a very, very slow moving tool. So okay, so we'll make this slightly different. Okay, so this roughing feed rate, this is actually going to be quite a large figure, because we're going to be dealing with, this is millimeters per minute, don't forget. So we're going to say 3,600, enter. Now that translates to 60 millimeters a second. So we're going to go 800 and press enter. So there, that's fixed. So don't forget, that's millimeters per minute. And just to roughly translate, that figure is 60 millimeters per second. Next one, we really don't need to worry about that. Job 00, top of the workpiece, that's okay to stay there. Okay, rapid height. That's a bit slow, so what we'll do is make that the same as the plunge rate. So that's 800. Step depth. Okay, we want to go down, let me see, about 3 millimeter a time. We can probably go to 5 millimeter, I think. So 5 millimeter, that's fine. Okay, so we're going to make this 0, 0. And it's, if you notice, this is highlighted here, this corner. So we're going to use this corner as the start off, or the 0, 0 point. Same as AppCamp, this corner, this corner, this corner, this corner, or the center. We're using the this corner over here. Okay, the length of the material, 330. So it's 330. Oh, I didn't highlight it. 330. Enter. And in Y, I'm going to say 300 for that. Enter. And the material depth really doesn't matter at this stage, but we can say it's 20 millimeter. There we go, that's better. Because this is oak. I'm sure the machine will do it at 5, but I don't want any tear out. Now you have a choice now of climb milling or conventional milling. I always find climb milling is probably the best. Okay, so there we have now made the code. There it is there. But at the moment, Mach 3 thinks that the 0, 0 position is right there, the same position where our machine home is. Of course, when we get this onto the machine, we can reposition this within Mach 3. So there it is. It's as simple as that. You fill in the dialog box here, or wizard, and post the code, and there it is posted there. And we can now exit, I think, and there it is in Mach 3, ready to go. And obviously if we, and here is the actual G code here. And that's what G code looks like. So what we can do is when we set up the G54 or the work offset, this, we can put this actually anywhere on the bed that we wish to. So that is how to fill in a wizard in Mach 3. So next we're going to do the same process in AppCamp. Okay, so now we open in this case, AppCamp Jewelsmith. I bought this program in 2008, 2008 or 2009, somewhere over there. And it's an excellent program. I also have the new AppCamp standard as well, but we'll use this one as I have this on this computer. Okay, so we're going to start a new job. Just fill in this. So the Y is 330. The X is 300. Okay, now we're just doing a straight surfacing cut here. We're not making a 3D relief, so we can use a low resolution for this. And we're set in millimeters, and we say OK. Just make that a little bigger. Okay. Now, very simply in AppCamp. Now, we've told AppCamp this is the overall size of our work. So what we need to do is go into the drawing vector tools. A vector is just a line. Circle, anything, any line, circle, curve, it's a vector. So if you go onto there's a little triangle here, any of these that have a little triangle, hiding behind it, there are other tools to use. So you click on that and you get a little flyout. And in our case, we do want to use the box drawing tool, and you get a dialog box that comes up, or a wizard. Now, we're simply just going to position the cursor just somewhere close there, and draw it over there like that. Now, we're fairly close, but not close enough. We're going to excuse me, we're going to make it exact. This one is width, which is the X, that's 300, and the Y, 330, and we do not want rounded corners. The tool's going to leave a rounded corner anyway. That doesn't concern us. I'll show you more about the other things here. It's already set in the middle. Now I have what they call snap turned on because this is a CAD CAM program. So there is snap controls that you can turn on and off. I always have snap on. So it's taken me already to the it's centralized itself in the center of the work. So we can preview that, and there it is. I can either alter it here and position it wherever I want to, or you can press F9, which is the hotkey, I suppose. We want to create that and close. And you notice it's highlighted, so you don't have to do anything else. I can de-highlight that, but for the purpose of making a toolpath, you have to let AppCamp know what you want it to do. So you say, okay, this square, so it's highlighted, so you're communicating with AppCamp what you want to do with that square now. It's highlighted. And so you pull this down, and of course all these lovely tools. Now this section here is 3D relief tools. You can actually make a 3D relief from a drawing or a photograph, even colors, different colored parts of a print. You can actually manipulate and make a 3D relief with colors. So because AppCamp recognizes shapes, or and it also recognizes colors. So that's that. So we're going straight to a toolpath now. So we come down here, toolpath, and you have all these different types of toolpaths, 3D, different or various types of 3D toolpaths here. Whether it's well, I don't want to complicate things, so we're going to do a straight 2D toolpath. So we're going to come here, which is an area clearance. That's exactly what we're going to be doing. Okay, start depth. Well, the start depth, the start of the actual part that we want to cut is on the top of it. So the 0 position is on the face of the material, so we're going to leave that there where it is. Finish depth, same as Mark 3, 5mm. Allowance, not worried about that. I mean, this is really going into high precision work, because you can actually do milling with this as well. If you have a milling machine like a Mach or a SIG, something like that, CNC, you can get very, very high tolerances with this ArtCAM program. Machines say 15mm, that's fine. Although on our machine, our new machine, it'll probably read 15.3, because that is the height of the automatic tool setter. So it'll automatically set that anyway. So we're going to choose a tool now. So we're going to add a tool to the list, and we're going to say, oh, now there's something new within that I'm going to show you within AppCamp. We are going to create a tool in the tooling list. So this is wood and plastic, rough in, 2D finish. So we're going to pick a 12mm because that's the largest in this section, and we're going to copy it. Alright, so now we have two 12mm, and we're going to edit it. Okay, so here we are. It's a mill. It's actually a 2-flute cutter, but mill is the closest we can come to, and we're going to name this as 10. So it's tool number 10. It's an end mill, we'll call it, and we're going to say, I think 25mm. Let me just check. Okay, there's our cutter. It's a rotor cutter, and it's 25mm. So we're going to put in here 25mm, and that's the general description. It's in millimeters per second feed rate, and here diameter, so we're going to say 25. Step down, ooh, that's a little bit much, I think. So we're going to put 5 there. I thought it'd probably do it, but not a full width diameter cut. It wouldn't do it, I don't think. Probably stall out. 35%. This is standard. We can change this at any time in the dialog box when we choose this tool. Speed 15,000, that's fine. Feed rate, or I can go up to 50. We're actually going to change, I'll show you, we'll change that to 60 shortly. Plunge 25. I'm going to press OK, and we're going to select that tool, and here it is. So we've made a tool in the tooling list, and we've chose that tool. Step over. That's fine. That's fine. And we're going to change this to 60. I'm going to change this one to 30. So I'm just showing you that you can, even though you have preset it in the tooling list, the speed and feeds, you can change it to suit the job that you are going to do. So just come down, and we're going to do We're going to do an offset raster, climb milling. I'm going to start on the inside and work our way out. That's the way I prefer to do it. Don't have to bother about that. Add ramp moves. Yes, we want ramp moves. 10-degree angle. I'm going to go 25. 25. I would say, no, we want 25 millimeter. We don't want a minimum, because what happens, if you, the cut-in surfaces on these particular rotors, rotor tools, is there and there. So in the middle here, you're just relying on that piece of metal there to remove the material. So you want the cut-in surfaces to remove it. So you bring the tool down at a ramping angle like this. So the cut-in surfaces actually remove the material as it's going down, so it never comes in contact with this area. That's the way to do it. Otherwise you will get burning. Ramp start height, I would say 5 millimeter above. That's 5 millimeter above the material. Set the material. Thickness 25. It doesn't really matter, it's a block of wood. Top. So yeah, I like everything set at the top. It's only really, you know, you use a bottom offset or even the material 0 at the bottom if you're doing a certain types of 3D release. Let's just review what we've done. Finished at 5 millimeters. We've got a 25 mil cutter. Step over 8.75 millimeters. Step down 5 millimeters. In other words, we want to do it in one go, one pass. Feed rate 60 millimeters a second. Plunge rate 30 millimeters a second, which is fine. Spindle RPM 15,000 RPM, and it's tool number 10. We're doing a tool clearance strategy of a offset raster, starting climb milling, starting in the middle of the material and working our way out. We're using ramp, adding in ramp moves. We set our material up. I'm going to call this information. So if I want to use this again, I can to do another job, and I want to calculate it now, and it's done. So it's as simple as that. Of course, with AppCamp you have a lot more control over what you can do, how to manipulate the cut, than you do Mach 3. But Mach 3 Wizard is fairly quick, and I mean you can do it, make the G code in Mach 3 as well. My personal preference is this one. Okay, so really all you do now is close, and I suppose go to the 3D and simulate all tool paths. Yes, go. Boom. It's done. And you notice there's little tiny corners on there showing as uncut, but in actual fact I have made the material size within the drawing here about 15 millimeter larger than what it all actually is. So these corners won't be left there, they will actually be cut away. So that's that. And then all you do then is save that code to your flash drive and then put it into Mach 3. Okay, so you can do the same job in NC Studio. You just need to come up to Operation and come down to Advanced NDI, and you have a choice of several different dialog boxes or wizards. So it'll do a frame, it'll do a round frame, or contour I suppose. It'll do a circular pocket or a rectangular pocket. Very simple. Look, I have used this. Like I say, I prefer to use AppCamp. It's much more controllable, far more controllable than this one. This is my, should we say, least favorite. So in this particular one, what you do is similar to Mach 3, but this one is less controllable even again. Right. Depth 5 millimeters. Tool radius 25. Oop. That's better. No, it's not. That's too much. I had numlock turned off. There you go. 25. Space. Now that's sometimes the translation doesn't come over particularly sort of well. What this means is the step over. So we're going to say 8 millimeter step over. This is material, so it's in Y, it's 330, and in X it's 300. I suppose this is the quickest, and of course you alter the RPM with the sliders. Start point, left bottom corner, so it's, you don't have a choice. It's going to start here at this corner, and the 0 point is going to be there. If you wanted to start over here, you would have to indicate in here, put the numbers in here. From here, you'd have to work out and put the value what it would be over there, or have it to put the value there. This is why this program, or this wizard, isn't very forgiving then. This is, like I say, my least favorite, but you can use it. And that's all. That's really all the numbers it's going to allow you to put in. And another thing with this program, it doesn't give you any time to do anything. It's in, and it's going to cut it. That's the only problem with this one. So you can pause it. Okay. So that is the only problem with this program. As soon as you say, like, post the code, the program takes over. This is one downfall with NC Studio, but you can actually create a G code within NC Studio. But as you just saw, as soon as you post the code, the program takes over and it's off and it's running. So there you go. Those are the three different ways then of creating a small program for a surfacing job of a piece of material. Okay, so I've now re-zeroed the X and Y coordinate, and this will jump into the correct position when I press reject. There it is. So Mach 3 will prompt you and show you, well, is this where it is? and then it's up to you then to visualize, well, is it right or is it wrong, as we've just done. So the next thing we're going to do now is use the automatic Z tool height setter. Okay, so with this particular machine, this PT6012, it has an automatic Z height tool setter. So what you do, you press, I've just determined that the highest spot of this work is here. So what we do then is, I'll just leave that there a second because this will come down very slowly. Now with this particular pendant system, press FN and probe. It gives you time to get this under, and I'll come down and touch it and register then to Mach 3 the exact height of the peak of that piece of material. There you go. This is also magnetically mounted too. So right, now this is now set at the machine home position. So what I'm going to do is I'll leave this door open so you can see the tool cut in, and I will, there won't be much talking during this the machining process because I will have the dust collection unit on. It's a bit noisy, so you wouldn't be able to hear what I'm saying anyway. So here we go. Okay, so we've now gone over the whole surface, and I've actually repositioned the 0 point further over this way because it's just going too far over there. So now we set the new Z height, which is simply done like that. Having set the new Z height now in the program, we just now restart the program. Okay, so this is 25mm cutter, and that's how it machines it down. And this is oak, by the way. It's very hard wood, and so that's how to write a program in 3 different programs in G code to surface a piece of material. And what we're going to do, if you can see that without too much interference of light, that is a grayscale picture of an eagle coming into, I don't know, land or snatch a piece of prey. Okay, so that was a fairly simple G code program creation, or a creation of G-code to do a simple surfacing of material in 3 different types of programs. I much prefer AppCamp for any G-code writing because it's so manageable. Secondly, I suppose Mach 3 would come in at a, I use Mach 3 at a push because you can also write G-code for small jobs in Mach 3. NC Studio, I think I've only ever once or twice actually written a G file to do a cutting process because it is not really that manageable. So anyway, so the next video, what I will do is I will take this grayscale picture of an eagle and I will put it into ArtCamp, pull it up into a 3D relief and make the file, make the toolpaths, create the G-code, and we'll cut it on the machine. So I hope you've liked this video. If you have, please press like, subscribe to my channel. That's a really good thing to do. Little red box there in that corner, if you're viewing on a computer or a television, you go into that, that'll take you straight to my YouTube channel. There you will find CNC routers, the programs that run through CNC routers, AppCamp, Mach 3, a little bit of NC Studio, furniture making, a little bit of 3D printing. I think there's something there for everyone. So until next time, I hope you join me again. Bye for now.